Do you see it?
No. Sorry.
You'd think it says live.
Probably a bit of a delay. Apparently I had to refresh the page.
There it goes. You got this though. Of course. So how do I get that to not do that? You just don't want to do that. Yeah. That's what I did last time. Swap this way. I was going to put that over there.
It's delayed.
That's not what we wanted. Is there a mirror option?
Oh, up here. Mirror built-in display.
Let's try this now.
No.
Did that work? Did it break everything?
Oh, yeah.
There you go.
Looks good.
That's good. All right, great. Sorry about that. So most of you guys know me, Jesse Altman. This won't be a super long talk. I just want to focus more on the concepts behind mocking, why mocking is very important, the benefits of it, and then I am going to get into ApexMocks and how you'd actually use it and some of the syntax behind it. What's wrong?
This split screen happened again.
It's showing this one?
Yep.
Oh, whatever. Anyway, so I'm a software engineer with Financial Force. I've been there for, I don't know, like 10 months now. And then if for any reason you want to, follow me on Twitter. So if you have any questions during the live stream, anybody out there, you can tweet us, or I have Peter monitoring comments, so feel free to ask there. So the obligatory about page. It's a little bit about Financial Force. We have offices in San Francisco, Harrogate, Granada, Toronto, Manchester, and Sydney. I believe we're in the process of opening another office in the Midwest. This is a slightly old slide. It's from Dreamforce, but I think we're at the 450 employee mark now. Our customers keep growing, a large amount of growth, and a lot of this growth has been funded by an investment from Admin International. Luckily, the growth is continuing, and for anybody who's interested, we are going to be hiring for the foreseeable future. So on to the good stuff. So what is a mock object? So a mock object's relatively simple once you wrap your head around it. But in my mind, the best way to do that is just by looking at an example. So let's take this piece of code that we want to test. And this piece of code might do a lot of different things. In this scenario, it's going to call out to 3 different services. The problem here is that we don't really have control of these services. The only thing we're testing is this code. Imagine you're building a controller and you're working on a team of like 5, and you have a couple other people working on your service methods that your controller is going to need. When you're writing your tests, you don't necessarily care what those services are doing. It doesn't really affect that piece of code that you want to test. The only thing that matters is that when you give it a certain set of parameters, you expect a certain result back. So the problem with this current approach is that when you test this, it relies 100% on these services. It'll go through and it'll call each of the methods, and they can do a lot of different things. Maybe they'll call out to a web service endpoint, or it'll mess with the data layer, and then you have triggers firing, workflow rules, all kinds of stuff that your piece of code doesn't really need to rely on. So what's the problem is, the real issue is you get unexpected results. As we all know in programming, unexpected things are awful. We want to know every single thing that our code is doing. We really need it to be exact. And the idea that, at some time in the future, somebody might change a service and it breaks your piece of code, specifically your test, because you're supposed to be testing that single unit, is a problem. So how do we fix this? Well, we introduced mocks. So the idea here is that instead of calling out to your services during your test, you're going to call out to mock implementations of those services. These mocks are going to be 100% controlled by your test code. And the general idea is that you'll be able to say, say you have an account service that you're calling out to, and there's a get account by ID method. You don't really need to know what that method does. All you need to know is that when you pass, ID X in, you want this account back. And that's the power, is that instead of actually running all the data processing or hitting the data layer and pulling out SQL queries, you just basically implement your own and can completely control it within the confines of your own test. So if the only thing you take away from this whole talk is, I want it to be this: just keep calm and use mocks. I'm really proud of that graphic, by the way. All right, so what exactly is ApexMocks? ApexMocks is a couple different things. First, it's open source. So it's a pretty well-known concept. The general idea is that the code is freely available to anybody who wants to use it. You can use it in commercial apps. You can use it in private apps. You can do whatever you want with it. The only real caveat is that you're not allowed to package it up and sell it and say it's your own, which most people wouldn't do. But basically, it's free for anybody to do whatever they want. I mean, the other beauty of this is that I'll show you the code base eventually, but it's relatively straightforward and simple once you start using it. So there's a lot of extension points and a lot of different things that you might want to do with it. So you can easily fork the repo, make your own modifications, and run your own private version of ApexMocks. Or if you would like, you can put a pull request in and get that into the general code base. The next great thing about it is it's Mockito-like. So for anybody who's not familiar with Mockito, it's a unit test framework built in Java. It's currently maintained by Google, I believe. But the beauty of Mockito is its syntax. It's incredibly readable. You could probably pull a line out of Mockito and show it to anybody, and they'd be able to give you a good guess at what it's saying. Basically, what it does is it'll read like, when this class's method is called with these parameters, then return this value. And it's that straightforward. One caveat to all of this is this ApexMocks, it's not Mockito. It's very, very limited compared to Mockito. Mockito is much larger. It's a much larger effort. The end goal would be to implement every Mockito feature eventually. We're not there yet. And I'll talk about some of the places we lack as we go on. But if you go and if you find something that you loved about Mockito and it's not available in ApexMocks, it's open source. Feel free to add it. And finally, it's written in Apex. I like to call this one out specifically because, in a traditional programming language, when you want to add like a library like Mockito, you just kind of throw, I'll use Java as an example, like a jar file in there. It's not that simple with ApexMocks. You actually have to include the code. So, because there's no packaging or anything like that, this code could eventually become part of your code base. So there's some different things you're gonna want to do to make sure that you're not necessarily editing or adding this level of complexity to your own code. You're gonna want to keep that a little separate. There's a lot of different ways you can do that. One would be just not pull the code down into your IDE so you never edit it. And there's a couple different ways to deploy it really quickly too. I'll show you. There's a button on GitHub you can use. It's a single button press. You log in and it gets deployed, and you don't have to worry about anything. Another is at Financial Force we use Ivy, and it handles all of our dependencies for that. And it's just basically hook it into your deploy scripts, and it deploys this as well as other libraries that we use. So what's the end goal of using something like ApexMocks? Well, it's getting to behavior-driven development. or test-driven development. Now, I don't want to focus heavily on either of these two topics because, I mean, you could probably do a whole talk on either of them. But I do want to talk about test-driven development for a second, just so the concept's understood. So the idea behind test-driven development is that you will always write your unit test first. The goal is that you're writing your unit test against, like functional requirements rather than the bias of your own code. So the way this would work is, in its simplest form, if you want to get really specific, would be something like you create your test class, and the only thing you're going to instantiate is your actual class. But because that doesn't exist and it fails, you then go and write the code just to make that pass. So then you write your code. Next is you're going to write your method. So you're going to test if the method's there. It's not, it's going to fail, and then you have to write your method. And then it'll continue to build. And the idea is that you constantly iterate, starting with the test and adding just enough that you can get to the next step. And the whole point is that as you go, it keeps your code very clean, very simple, but more specifically to the requirements. Your requirements are the driving force, not the code you've already written. So the goal or the dream is to have TDD in Salesforce. We're not there yet. We're not even close. Even with ApexMocks, there's a lot of things that Salesforce really lacks. For one, you don't have control over when your unit tests run. So you queue up your unit tests and they kind of run when Salesforce wants them to. Another big issue is you can't run a single method in a unit test. So it causes you to run the whole class every time. Just more delay in that iteration between running tests, writing code, running tests. Another big problem is typically you have to instantiate a large chunk of the data model before you do any tests. And that has a lot to do with the fact that Salesforce is more about integration tests than unit testing, and I'll touch on that in a minute. But unfortunately, until something else happens, we're not going to get there. The good news is ApexMocks does help a lot. You should see a dramatic improvement in test speed with ApexMocks, mostly due to the fact that you're really not hitting the data layer much. You're going to instantiate objects in memory, and for the most part, just pass them in through mocks, rather than having to retrieve all that data from the database. That's not true in every instance, but it's true in most. It should help speed things up. The second is that it is working more towards real unit testing. So you're testing smaller chunks of code, which subsequently will be a lot faster than having to traverse through all the code that gets run with every single call. So, as I kind of mentioned a little bit, we're going towards the real unit testing with ApexMocks. And the general idea is that you just want to test a single piece of code. The best way that I can explain or show this to you is just by kind of giving you a code example. So let's take a look at this. So we have our controller, and it's pretty simple. It just calls a single method. Then we have our test class, and you'll see we instantiate our controller. We call our method with 5 and 3, and we get our value back. And then we write our assert statement. So what do you guys think? Pass or fail? Yeah, exactly. Nobody knows. There's no way to know if this passes or fails, because while we're trying to test this single unit, this single method of calculated total value, we are forced to also test my services calculate values. It's not really testing that unit, it's testing the whole system, because my service calculate values could do anything. Maybe it takes those values, passes it to a web service, creates an account with 10 opportunities, and deletes the opportunities, and then calls a bunch of workflow rules, and who knows. And that's the real problem with Salesforce that ApexMocks tries to solve. So the general idea is that when you have multiple units, it's not unit testing, it's integration testing. You should be testing each unit separately, the service layer separately, the data layer separately, the view layer separately. It's not a good idea Well, I don't want to say that necessarily. It's not unit testing if you test them all together. There are good reasons to do integration testing as well, but the reasons are different than for unit testing. So how does ApexMocks kind of solve this? Well, the cornerstone of it is dependency injection. So basically, anything that your code needs to run. In the last example, we have my service, but also value 1 and value 2 are considered dependencies. Basically, your code is dependent on it. It's a pretty simple concept. Dependency injection is the idea that you'll take that specific instance and handle it yourself outside of that class and pass it in through the constructor. So in this scenario, you could refactor your code to pass my service in. So you'll see here, instead of just calling a static method, you're actually passing an instance in. You're going to set that on your controller, and then you'll use that. So technically here, you are using dependency injection. The problem with this way is that the value you get from it is very limited. I mean, you're passing an implementation in, so the only thing you really control on it are the instance variables on that actual implementation. What we need to do is take it another level further. And in order to do that, we need to start using interfaces. So interfaces are basically a contract that says, if you're going to implement me, you have to have method A, B, C, D. And the idea here is that when you're calling code against an interface, you'll be able to write as many implementations as you want against that interface. And then the code that actually runs it doesn't care what that interface does. A perfect example I like to use is a payment processor. Imagine you're building a payment processor, right? You have the basic things on your service, process payment, process refund, get order number or something like that. And it'll work. You have a customer come in and they want to use Stripe. So you write your code and it works with Stripe. But if you're not using an interface, maybe your next customer comes in, they want to use authorize.net. So what do? I mean, you can start having all of your methods with if statements in there, trying to figure out, if authorize.net do this. But that kind of gets messy too. The way you would do that is you create like a payment process interface, and then you have your Stripe payment processor implement that interface, and you have your authorize.net payment processor implement that. And whatever other payment processors you want to use, PayPal, anything. And the idea is that your controller or whatever other code's going to call it doesn't care if it's authorize.net or Stripe or PayPal. All it cares about is that it wants to process a payment. So if you look at the code example here, you'll see that we are now using an interface, and our interface has calculate values. We have our implementation, which calls or implements our my interface and also sets up the method. And then we have, as part of our controller, we'll be injecting our implementation based on our interface. So we're not calling any specific implementation in our controller. All we're calling is methods on an interface. And this is really important to the whole concept of ApexMocks, because essentially the way ApexMocks works is it's going to take these interfaces and it's going to create mock implementations of them. There's a script that you can run that actually generates these classes. And what you do then is, as part of your testing, instead of passing your implementation in, you just pass in your mock, and then you control everything. There's a lot of ways to do this. The first we're looking at right now is just passing it into the constructor. A lot of the feedback I got from the last time I did this talk was that this isn't really viable, and I agree. So some better ways of handling interfaces and passing them into controllers and services and other classes, specifically, is Apex Enterprise Patterns. So there's another open source library called ApexLib, and there's a ton of great documentation, and there have been Dreamforce talks on it. There's just a ton of information out there on this process that you can use.
You got a book?
And there's a book. Good point. But the general idea is that this is really taking Salesforce and Apex and Visualforce and stuff to the next level. You have a domain layer, a selector layer, service layer, and it's really starting to separate out the concerns. And there's a lot of different things that kind of happen behind the scenes with the open source library ApexLib. But the general idea is there's this application class that handles mapping all of your implementations to your interfaces. And ApexMocks is incredibly powerful when it comes to that, because all you do is, as part of that application, is you override which implementation you're going to pass in. And then you pass your mock instead. Makes it very simple. You don't have to worry about passing anything through the constructor or anything. Just a matter of setting up, okay, this is my mock, this is what I want to use, and then it runs. Another way, give myself a little plug, is you can use custom settings with type.forName. The idea there is that type.forName accepts a string as a parameter, and it'll instantiate the class of that string, the class name. So the idea is that you'll have a custom setting that has each implementation. You can basically just give it the string name of the class that you want to use, and it'll instantiate that, and you can run it. I've been told that it's not really dependency injection, so it's more service locator pattern. So you can kind of check that out yourself. But I would highly recommend Apex Enterprise Patterns over that by a long shot. That's just something I did in my spare time. All right, so what are you guys here to see? ApexMocks. So here's our code running with ApexMocks. So almost every unit test looks similar to this. You'll see you instantiate a mocks object. You will pass a new implementation of mock_my_service, and I'll show you that in a second. But that accepts the parameter of mocks, and it implements your interface. And this is the real power. That's where your mocking is going to come from. So what you can do now is you can actually start stubbing out. So you'll call mocks.startStubbing, which basically just allows your method to record, or allows mocks to record what parameters and what return value should happen. And then just like Mockito, it's very readable. Basically, it says when mock_my_service calls calculate values with the parameters of 5 and 3, return 8. It's that simple. You can mock as many of your methods as you want, mock as many of your services as you want. Now, this is where I was kind of talking a little bit about not being to Mockito's level. There are some limitations on how many times you can mock the same method. I know there's work being done on that recently, so I don't want to say anything specific. But you can't mock a method out 5 times and say the first time it gets called, return 5, next time return 4. You know what I mean? It's just a limitation we have currently. Anybody who's interested in solving it, feel free. So back to our test. So we'll stop stubbing, and then we're going to instantiate our controller, and we'll pass in mock_my_service. So if you're going to use one of the other patterns, like Apex Enterprise Patterns, before this, you're not going to pass your service in through the constructor. You would basically set it on your application class, which would handle mapping. And then you can call controller.calculated total value 5 and 3, and then you can guarantee no matter what happens in that implementation going forward, this will pass unless your code changes. So what you've really done here is you've taken all of the control and put it in your own hands. Nobody else's code can break the stuff you've written. And the beauty of it is that when your test fails, it's something with that piece of code. Previously, if somebody changed something down the chain, right, and it broke your code, you might get failing unit tests all over the place. But that unit wasn't really failing. It was what I would call a false positive. So this makes it very clear when there's a problem. So if you have your unit test running like a Jenkins build, you'll know exactly where to start. And it's, if your methods are small enough, you'll have a pretty good idea of where the error is right away. So I mentioned I would show you mock_my_service. So don't be alarmed by this. Like I mentioned, this is all 100% generated by ApexMocks. But I kind of wanted to walk you through because it's pretty cool. So what happens is you're going to instantiate your service with your mocks, and then you have your calculated values. So if we go back, we'll see we're going to start stubbing here, mocks.start stubbing, and that sets it up so that when you come and call the calculated values the first time, it's going to run through and prepare your return. So you'll see basically it's going to call start stubbing, and then it's going to call that method with those parameters and set up that when for that then return. And then you're going to stop stubbing, and then when you pass this into your controller and it gets called again because it's not stubbing, it's going to go to the second half of your if-else. And it's going to record that the method ran, which is important for verify. I'll show you that in a second. But then it'll get your return value. And if your return value is not an exception, it'll just return that value back to you. So you can also throw exceptions with it. So it's pretty cool. Almost all of your mock services will look like this. It's going to generate every method on your interface and put it up there. But I think it's interesting to understand how it works. So what other features does ApexMocks support? So ApexMocks supports verify. So the idea here is that you'll set up your mocks, you'll set up your mock service, and then you'll do your test. So and maybe instead of stubbing, you just call a method, and then you're going to call mocks.verify against that class, and then you're going to call the method with those parameters. So the idea here is, maybe you have a method that you want to test that calls a service that doesn't return anything. So you're not really stubbing anything out. You don't have any return value to test against. But you want to test that the path your code went through hit the right service. This allows you to verify that method actually was called. And if it's not called, it'll actually error out just like a system.assert would. So it gives you the normal kind of functionality to expect from that. There's a couple different overridden versions of this. You can verify that a specific amount of times the method was called. So in this instance, this would fail unless calculate was called 3 times. And then there's also another version that there's some constants you can use like never. So maybe you're testing an instance where you're what am I saying? TV threw me off. Okay, yeah. So maybe you're testing an instance where you want like a logger to catch like an exception and log it out. You want to make sure that nothing gets logged out and no errors actually occurred as part of your method. So basically you verify that it never happened. And then when, so this is one I showed you already. Basically just let you mock, when a method gets called with a certain set of parameters, simply return a value. But we also have then throw. So a really difficult piece of code to test in Apex is typically your exception handlers. The problem with that is that a lot of times you write exception handlers because it's something that you didn't expect. Maybe like a DML exception or something like that. This is a good method for testing that logic and getting that code covered and making sure that everything happens the way you're expecting it to. So the idea is that if you're passing invalid parameters to a method or something as part of your logic, that you want it to throw an exception to verify that the code you have written works properly. So for the most part, that's basically it for ApexMocks of what it can do now. It's still very limited. I'll talk in a minute about where we'd like to go with it. But I do want to point out the ApexMocks Generator. So there's a jar file that's included as part of the ApexMocks. And you can run this simple ant target. And basically what this is going to do is it's going to go through a property file where you're going to map your interfaces to the mocked implementation name you want to give it. It'll grab those classes from your source path, and it'll grab the interface class I just mentioned. It'll set a class name. So in order to keep your code base a little cleaner, it puts all of your mocked implementations as subclasses under a parent class. So in this situation, it would be mocks. So the idea behind that is that instead of having, if you have 500 services or whatever, you'd have 500 mock classes all throughout your code base, just kind of littering the place because it's not code you actually use directly. In this situation, it keeps your mocks class marked as is test, so it never affects your code base. But it also keeps it kind of encapsulated and makes sure you don't have duplicate sets of code anywhere. And it makes it kind of cleaner. Then you can set your interface just be, my interface equals my interface. And then the mocked one is going to be mocks.myInterface. And then you have your target path, which just throws the code back out there. So the code repo. Let me. So I wanted to show you guys the code repo just really quickly. So we have a bunch of documentation up here that you can kind of check out. Paul Hardiker, the guy who originally wrote ApexMocks, has a blog with tons of different articles on there with information. A really cool feature is this deploy to Salesforce button. So if you click this, it'll open up a page that looks like this. There's nothing you have to change. You just hit log into Salesforce, and it's going to work like any kind of third-party tool that you're connecting up to Salesforce. It'll ask you if you want to allow the GitHub Salesforce deploy tool access. You say yes, and it immediately gets deployed. So this is a good way if you don't want to try to loop this into any deploy process. Just make it so that when you want to throw ApexMocks on a developer org, just log in here, hit go, and it's up there, and it'll stay out of your ID that way and everything. Finally, you'll see the jar files here. Use the latest one when you can. But I'd like to show how kind of small this is. It's very simple. Most of the things are done in ApexMocks, but for the most part, there's not a ton to it. Even my list is kind of an example. So when you're trying to use this or you're thinking about using it, it's good to remember that it's going to be pretty simple. Even if you wanted to do your own thing with it, you can come in here and modify things, and it's not going to be overwhelming at first. That sometimes can be a barrier to entry. So there we go. There we go. So how can you help contribute? So a couple of different things that we would love to add. Specifically, matchers would be awesome. So the idea behind matchers is, we have those whens when we're calling a service. We're passing in specific parameters. A matcher is that instead of passing 5 and 3, all we say is any integer, and then you pass that in. And then instead of having to match a specific value, all it really cares about is that it hits, that kind of more global spectrum. You can even do stuff in Mockito to use any object, any string, any a lot of different things. So matchers would be really cool to get in there eventually, because it might make some of the other things a little bit easier to test. Sometimes you don't really care about the parameters, and that's when this situation comes into play. Documentation is something that we could use more help on. There is some on between Paul's site and my site, and then the GitHub repo. But for the most part, it's kind of lacking. I want eventually to do something where I kind of explain using ApexMocks with ApexLib, because that's where it truly shines. I just haven't had a chance to do that yet. And then more. I mean, if you guys have any awesome ideas, most of you guys are awesome developers, so I'm sure you probably could think of other great things to add. But feel free to fork the repo, do whatever you want. It's all open source. So, told you guys it'd be short. Any questions?
Is there, I don't even know if it's possible, but is there thoughts on trying to make it so you can mock S objects?
Well, Yes. Well, not in ApexMocks. So ApexLib uses this concept of selectors, which basically selectors are going to wrap your S object, and you can do a lot of different things there, like CRUD checks and FLS checks. But the idea there is that your code would then use your selectors rather than S objects, so that you can just mock your selectors out and pass those in, rather than trying to mock an actual object instance. So I'm not sure if that makes sense or not. ApexLibs would solve that, yes. Anybody else?
How upgradable is ApexMocks? Like, is there a new version? Is it just a matter of regenerating your mock classes, or has there been kind of more significant refactors during development?
As far as I know, you probably wouldn't even, unless something significant happened, you probably wouldn't even need to regenerate it at this point. It's been pretty stable from that perspective for the last couple months. As far as actually updating the code, it'd just be a matter of redeploying. The generator only takes a couple seconds to run, depending on how many classes you're mocking out. It's Java on your desktop, so it's going to be pretty quick. What we do sometimes is loop in the generation of the mocks as part of your deploy, and make sure you have the most up-to-date version, and make sure you didn't miss anything that would cause like a deploy failure or anything like that, because it's just an ant target. But that would probably be the preferred path, is update your code, regenerate your mocks, you save that mock class, and then you're good to go. Anything else?
Good question. So let's say you're not currently using ApexMocks, but maybe it's something you want to do in the future. Is there anything you can do now to kind of set yourself up to make that easier?
Sure. It's a good question. You gave me a warning about it earlier. So I'll give you an example. I work on the HCM product at Financial Force, and we were not using ApexMocks until relatively recently. What we have done is basically it's sort of like implementing any new pattern, right? You're going to start with the new logic, new piece of code you're working on, and you're going to start implementing those patterns. So my suggestion would be to start using ApexLib. ApexLib is really built to work with ApexMocks. So start using ApexLib in your development code, and then as you progress, start adding ApexMocks into it, and then just build from there. You have your new set of code, and you work from that. And then anytime you need to change your old code, adding these things isn't going to break the way your old code worked. It's not like a global sweeping change that if you didn't have it at the beginning, everything's broken. The idea is that you kind of just start implementing it, and then as you need to make bug fixes or whatever, you do a little bit of refactoring, a little bit of cleanup, and before you know it, huge chunks of your code base will be using these new practices. And I think all of you guys would actually love it. It's pretty cool. When I finally started drinking the Kool-Aid, it was a good experience. Anything else? Anybody on the live stream ask us anything? No. Thanks, guys.
So your sample mock methods demonstrate passing in primitive values. I think Jeff asked about being able to mock S objects, but passing S objects in as an argument to the method that you're mocking. How does ApexMocks work with those and the quality of S objects, or should we actually just be passing in primitive values?
It doesn't have to be primitive values. You can pass in classes. So if you have a wrapper class you want to pass, or S objects, they all work. I'm trying to remember the exact equals implementation. But it loops over your objects fields and does like a field comparison, so that if the value that's getting passed in when it's actually running should match the same, not reference, but the values on that other object. Does that make sense?
Yeah, like a deep comparison.
Yeah, so it'll compare all of the fields. So if you're passing your account, your name needs to be the same, your billing address needs to be the same, XYZ. And a lot of times you'll end up passing like empty objects because you don't care about the fields on them. That's normally for the service that's going to care. But yeah, it'll look at each field. Good question. Anybody else? All right, great. Thanks, guys.
Thank you, Jesse.